Welcome to Easy Gates Gate 22 Instrumentation Solutions. Next problem, problem number 63. So probably you have come to a state of mind that the paper is not very tough, instrumentation paper. So once you connect it to the fundamental, it's very easy to answer all the problems. Okay, little manipulations. Okay, so time consumption is it was there in some problems, but rest of the problems are a normal only. Okay, familiar one. Okay, familiar to whatever happened till gate 2021. Okay, so let us get into the next one. Next one from circuits. Okay, so exactly basics of AC circuits only. Such a problem already happened. Okay, as per my memory in easy paper. Okay, so probably in the past 5 or 6 years it happened. Similar problem only. It's also based on a sine wave generator. Okay, yes, let us get into this. So we have a 1 kilohertz sine function generator having an internal resistance of 50 ohms that is generating a open circuit voltage of 10 volt peak to peak. When a capacitor is connected across output terminals, the voltage drops to 8 volt peak to peak. Okay, the point is this. So that means you can model your source as a practical source. So what we have is the source can be modeled as Vs and Rs, the Thevenin's equivalent or the practical source equivalent. So Rs is given, source equivalent is given, source internal resistance is given as 50 ohm, and this is given as a Vs. So what is given is an open circuit voltage. So open circuit voltage is given as 10 volt peak to peak. That means when nothing is connected here, so the open circuit voltage is 10 volt peak to peak. What it means? It is nothing but your source voltage. So indirectly is passing the information. The source is 10 volt peak to peak. Okay, of frequency 1 kilohertz. That's your source given. Okay, so you can take that way. Then a capacitor is connected across output terminals. Yes, connect the capacitor now. So the first statement gives indirectly the information about your source Vs. Okay, sinusoidal source Vs of 1 kilohertz frequency. Now let us connect the capacitor. A capacitor is connected of value C. So because of this connection, the voltage is actually now falling to from 10 volt peak to peak to this is now falling to 8 volt peak to peak. It becomes 8 volt peak to peak. So let me call this as my V0 now, and this is my habit V in. So this is going to be V in of S in S domain, and this I can call it as V0 of S. So we can find a simple transfer function connecting the two. So it is going to be V0 of S by V in of S. Okay, so that is equal to, since you are familiar with, otherwise you can straight away play for the nodal, potential division. So take this as R, take this as C. So therefore it is going to be, the voltage is taken across 1 by SC. So 1 by SC, that's impedance offered by capacitor. So divided by the total impedance of the circuit. Okay. So if you reduce this, you'll end up with V0 by V in of S is equal to 1 by SRC plus 1, a simple low pass. Okay, it's a frequency selective network, a simple low pass first order system it is. Okay, so the point is this. So the output voltage magnitude is 8 volt and input voltage magnitude peak to peak is 10. So what we can do is we can play with the transfer function straight away. Let us set S equal to j omega, and then we'll focus on V0 by V in of j omega magnitude. Okay, since we know the magnitude of V0, magnitude of V in. Okay, so then it is 1 by j omega RC plus 1. This magnitude will take. So V0 peak to peak and divided by V in peak to peak. Let me take directly this as a magnitude. Okay, that should be equal to 1 by root of omega RC the whole square plus 1. So this is V0 peak to peak is 8 volt peak to peak. V in peak to peak is 10 volt peak to peak. So the resultant magnitude is going to become 0.8. So 0.8 is equal to 1 by root of omega RC the whole square plus 1. So squaring both sides, the result is going to become 0.8 square is going to be 0.64. 0.64 will become 1 by omega RC the whole square plus 1. Then from this we can write omega RC the whole square is equal to, or omega RC the whole square plus 1 is equal to 1 by 0.64 we can say. Okay, that's better. So then I can write omega RC the whole square is equal to 1 by 0.64, definitely greater than 1 minus 1 we can say. Then this can be reduced into taking 0.64 as the LCM. So 1 minus 0.64 is going to become 0.36. So then omega RC is equal to, it is root of this. So it is going to be 0.6 divided by 0.8. So it is 6 by 8 straight away. It is nothing but 3 by 4. So it is going to be 0.75. Okay, that's your omega RC. The only unknown is the capacitor. So we conclude now omega RC is equal to 0.75 and then C is equal to 0.75 divided by omega into R. Okay, so R is given. That is nothing but your source resistance RS we can take. Okay, so it is going to be 0.75 divided by omega is frequency is given. Frequency is given as 1 kilohertz. Let me have a small check. Yes, 1 kilohertz. So then omega is going to be this 2 pi into 10 power 3 into RS is 50 ohms. That's all. So anyway, straight away I'll take it in farads, but the result must be in microfarads. That's all. So make the small adjustment, then you'll get the result, desired result. So then C is equal to, let me have a small check. So omega RC is equal to 0.75. That is 3 by 4. Then omega 2 pi F RS is 50. Okay then. So then 2 into 50 will be 100. So it is going to be 10 power 3. So 10 power 5 it is going to become. Rest is 0.75 divided by pi. 0.75 by pi into 10 power minus 5 farads we can say. Okay. 2 into 50, 100. That's fine. Okay. So then C is equal to 0.75 by pi. 0.75 divided by pi will be 0.23873. Okay, into 10 power minus 5 farads. Therefore, I can say C is equal to 2.3873 microfarad. So up to how many decimal places? So round up to 2 decimal places means then your answer must be 2.39 microfarads. Yes, that's your answer. A very simple problem. You have to find the transfer function between V0 and Vin and look for its magnitude. And with that, the only one unknown is the capacitor, a simple RC low pass excited by 10 volt peak to peak, and the frequency at which it is falling to 8 volt peak to peak is given. So the only unknown is the capacitor. So that's another interesting problem, an easy problem from instrumentation gate paper. Okay, so thanks for watching and do subscribe our channel. We'll update you with the next problem. Thank you.